right, welcome back. In this class, we're going to talk about a few things. We're going to talk about strings and look at some methods in strings and some ways that strings are used, including the toString method. We're going to look at scanners as a way to ingest information from a user at runtime. We already looked at command line arguments using the args parameter to main, but we're going to look at how to input from standard in while a program is running. And then I want to talk a little bit about integers and doubles as classes and talk about the difference between primitives and non-primitives and look a little bit at exceptions. I'm back on the Linux server and I'm going to make a separate file here and let's just make a class called S1. We'll make a main program. And we already played with strings a little bit, so let's just start off with a string variable. So string name equals Nick, and then we can do things like print that. And that's all pretty straightforward. So this is just a variable of type string. I'm saying it equal to Nick, and then I can print out the value of that. So I can compile this and execute it, and it prints out name equals Nick. All right, so that's not terribly startling or inspiring, but let's take a closer look at this. So let me go ahead and add some more characters to this, and notice that this variable is declared to be an object of type string. So what is string? So here's a good time to point out something important convention-wise in Java. In Java, when we have a class, it should always begin with an uppercase letter. It's not a requirement according to the compiler, but it's an absolute standard that you'll encounter again and again. So when you make a class, it should always begin with an uppercase name, an uppercase letter. When you make an object, it should generally begin with a lowercase letter. So string is actually the name of a class, which means that this thing name is like a super variable, right? That's what an object is. It's a variable that has possibly multiple fields inside it, but also has functions, what we call methods, code that can be executed. So the best general reference for Java documentations, I just do like Java doc and put in the name of the class that I'm looking for, and you should see a link to something on oracle.com. There's tons of information out there. A lot of it is just derived from what Oracle provides, but this is generally a good place to go, and you can find information about the class string. So we're going to look at documentation a lot in this course. It basically tells you it comes from what's called a package, java.language, which we have access to by default. The class name is string, and a string is a version of what's called an object. So we'll talk about extending classes later. So there's usually some words in the beginning that describe the class, tell you a little bit about what it can do, and so on. And so the string class represents character strings. Literals such as double quote something are implemented as instances of this class. Strings are constant, they cannot be changed after they're created. So for example, I can say string str equals double quote abc. That's what we did up here, right? And that constructs an object of type string and sets its value equal to this. But there are other ways that we can construct strings, right? So one way would be to use that new keyword and say, let's make a new string, and we want to construct it from this thing called data, which is a character array. We're not really going to do that, but it's an example of different ways we can construct strings. We'll skip over the field summary, we'll skip over the constructors, because for most of what we do, we're going to initialize a string just like this. Right, that's going to be good enough for now. But I want to go down a little further and look at the methods. So methods are functions that you can run as part of an object, right? An object of type string has all of these methods available. For example, character at. And I can click on this and get a better description. So character at returns a character, it takes an integer, and it returns the character value at the specified integer. So, you know, in C, strings are arrays of integers. We can get the nth character by saying array bracket n. But in Java, strings are not arrays of characters, even though they might be stored like that internally. They're just strings. But we have a method called character at that we can use to pull out the character at a particular position. So I could, for example, do something like this. So let's look at the characters one by one. So I'm going to say for I equals 0, I less than 10, I plus plus, and I'll do my system.out.println. So I'm going to say the character at position I is, and then how do I get the ith character of this string name? I say name dot character at parentheses I. All right, so what's going to happen when this line executes? It's going to say, okay, I want to call this print line method that prints the standard out. I'm going to pass it an argument, which is this string, followed by the value of this integer, followed by this string, followed by this thing. Well, what is name.character at I, right? It's a character. Name is an object of type string. When I run this method called character at and I give it an index, it returns a character. And so that character will get appended to this message. And if I close out my loop right there, and then I run this code, I can see character at position 0, 1, 2, 3, 4, 5, and so on. So I can break my string apart into individual characters if I want to, but I don't have to think of it like that. So this documentation shows us lots of functions, methods that we can run associated with a string. So let me go back to the index of these. Concat is a way to concatenate two strings. Compare to is a way to compare two strings to, see how they compare in terms of alphabetical order. Equals is a way we can see if two strings are equal, and we'll play around with that in a little bit. A really useful method is length. Returns the length of this string. So if I don't know how long my string is, instead of going up to 10, I could say name.length. And now it'll go through all of the characters. So you notice this one stopped at the letter A. But if I go up to length minus 1, then it goes off and it gets the 11th character, right, at position 10, which is the last character of the string. So length is a useful function, and there's a lot of functions in here. There's ways to replace characters with other characters. There's a way to find the index of a character, to look for where a character, what position it sits in a string, and so on. So all these functions are available once you have a string. And in C, when we want the length of a string, we call string length and we pass it the string as an argument. With objects, the string kind of comes endowed with a length method, and so we can say something like string name dot length paren, and that says, hey, run this length method on this string. So we start to think of this notion of encapsulation, that the data and the functions are part of the object itself. All right, so let's just play around with some other methods. So I can say name dot substring. And the substring method, there's a few ways we can call this. We can say substring and just tell it where we want to begin, or we can say substring and put in a beginning and an ending index. So if I wanted the first 5 characters, I could say name.substring 0, 5. And that begins at location 0 and it ends right before location 5. So that would be the first 5 characters. So if I run that, the first 5 characters are Nick. And this is a good time to remind ourselves that when you're exploring strings, it's useful to sometimes put delimiters around strings that you're printing out. So I'm going to put out a less than sign, and then print my string, and then print a greater than sign. And if I do that, I can see there's an extra space at the end of my string, so this really is 5 characters long. And if I put in 2 different numbers here, I could start from any position and go up to any position that I like. And if I do something like, try to go up to position 50, that'll compile fine. But when I run it, I'll get an exception. And the exception is string index out of bounds. And I asked for a string beginning at 0 and ending at 50, but it's telling me the length of the string was only 11. So this is one of the advantages of having an interpreted language running on a virtual machine. The error messaging can be a lot cleaner because the virtual machine, has full access to the environment and can report on unexpected situations more accurately. So we can do substrings, we can do the length, we could do index of to find where a particular character appears. So if I said the first space is at position, name dot, and let's use this index of method. So index of takes a string or a character and tells you where the first occurrence of that character is. So the first space is at position name dot index of, and I'll say space. So compile that. Go ahead and run it, and it says the first space is at position 4. And is that true? Well, yeah, this is position 0, 1, 2, 3, and that space is position 4. So we have all these methods available to us. So another useful method is going to be split. And split is a way to take a string and break it up into pieces. So in 222 we talk about string tokenizing. So using the string toke function to break up a string and read each piece one at a time. We can do something similar in here. So let me put my string in here and make it a little more interesting. So let's break this into fields separated by spaces. So I can do the following. I can say I want an array of pieces equals name dot split, and I'll just try to split wherever there's a space. So name is a string. It has a method called split. Split will look for places in the string where there's a space, and it will go ahead and it will return an array, right, a string bracket. And so I'm going to call that pieces, and then let's do some prints. So let's see how big our array is. Well, we can just do pieces.length. Remember, with an array there's a field called length, and then we can go ahead and say for I I equals 0, I less than pieces dot length I plus plus, and I don't want to keep typing system dot out dot print line, so I'll just repurpose my code. Piece number I is, and then I can do pieces bracket I. Alright, so number of pieces is this. That's the length of the array, and then for each element in the array, I'll just print out piece number, followed by an index, followed by some delimiters containing that element of the array. So number of pieces, my name is Nick Macias, 5 pieces, and there they are. So very easy to break things up, manipulate them, put them together, compare them, and so on and so forth. All right, couple of things here. You notice that when you compile, you have to say Java C. When you execute, you have to say Java. So I can, exclamation Java C to recompile, but if I exclamation Java, it's going to pull back that same Java C, because the most recent thing in my history that starts with Java was the compile command. And, typing this is kind of a pain anyway, and so on and so forth. This is a good place to, start taking advantage of the fact that you're working in a Linux environment. And so I could say, for example, alias C equals Java C s1.java for compile. Got to spell it right. And alias R for run equals quote Java S1. So now I can edit my program. When I want to compile it, I just hit C. When I want to run it, I just hit R. And then I can edit it. And I can make some changes, and I can recompile, and I can rerun. Right, so make your life easier, right? Make yourself some aliases. If I'm going to be doing this a lot, I could put this in, a little script and source that each time I go into this directory. Or, I could set up an alias for Java C and another for Java. And then I could just say, C s1.java and R s1. So, make your environment friendly and comfortable. Make yourself more efficient. All right, one method I want to pay particular attention to here is the equals method. So equals is a way to compare two strings to each other. And this is like string compare in C, right? Except it returns a true or false. But just like in C, we cannot compare strings by using equal equal. We can compare integers and doubles and things like that by saying, if x equal y, but we can't do that with strings. If we want to compare two strings, we have to use the equals method. So for example, I could do something like this. So I'll compare S1 and S2 by saying S1.equals S2, and if that's true, I'll print out S1 and S2 are equal. Else, I'll print out not the same. So if I run that, it tells me that, hello and goodbye are not the same. Whereas if I do this, then it'll tell me S1 and S2 are equal. So there's some experiments to run in the problem set that will help you understand or believe why we have to use the equals method instead of saying equal equal, because sometimes equal equal will do what you think, but sometimes it doesn't. So if you want to compare strings, always use dot equals. And a lot of different types of objects have equals methods specifically to tell you whether or not two things are the same. And by the way, I could also have said if S2 equals S1, and that would be exactly the same operation, right? Seeing if S2 is equal to S1, or seeing if S1 is equal to S2. Same thing. Your choice which way you want to go. All right, so that's a bit of basics about strings. Let's talk about documentation. So I'm using this page here that I got to by googling Java doc and then the name of a string, and this is obviously hyperlinked. So if I know that a string method returns a character, for example, or takes a character, I can click on pieces in here. Like if I know that this takes a character sequence and I want to know what a character sequence is, I can click on that and read about the character sequence interface. And if this thing returns an int stream, I can read about that. And I can also go back to the top page and look at all of my different packages, and like java.language, and I can see all the different classes that are available in there, right, including the string class and the math class and so on. So once you're on one of these pages, you can just kind of keep it open and look around pretty easily. But if you do a lot of looking up of documentation, that can get a little cumbersome. So I have a shortcut that I'll use at home often. It's just a command I call doc, and I can type in the name of a class, and it pops up the Oracle documentation that I made a copy of. And if I want to know what a linked list is all about, I can just say doc linked list, and it will bring up the documentation on that. So I've put a version of this on the Linux server, but we can't easily display a nice web page like this from code running on the Linux server. So it's using a text-based web browser. But in a pinch, it's not bad. So if I just say doc string, it will bring up a page like this. Takes some getting used to navigate, but I can skip forward by pages by hitting the space bar. And this is the documentation about strings. And I can space bar down, see the ways to construct, and then I can see the method summary. And if I want to search for something, I can say, slash and length, and it'll take me to the first occurrence of the word length. And I can do the letter N to look for the next one. So if you know how to move around in VI, those things work in here. And it's hyperlinked, so I can click here, and it will take me to the length method. And again, you can follow these links and get to the page on a character sequence and so on. And it's somewhat mouse friendly. I'm using my scroll wheel right now to move back and forth. So that's an option, and a queue gets you out. You can say yes, you want to exit. But get used to looking at documentation for Java. Don't go down the deep wormholes of Stack Overflow or Geeks for Geeks or things like that. Those are great sites. They're useful for very particular specific issues. But if you want to know what's the right way to tell if two strings are equal, and you go to Stack Overflow, you're going to find someone's dissertation on all the different ways to do this and the philosophical reasons for picking one way over another. And really all you need is the dot equals method. So go to the Java documentation, look through the methods, find the length method or the equals method or whatever it is you're looking for, and you're good to go. So get comfortable with the Oracle documentation. All right, next thing I want to talk about is a particular method called toString. And so I want to copy my rectangle class that we used previously. And I want to build on this. So this was our simple rectangle. It has a length and a height. We construct it with a length and a height, and we can find the area of it. So let me make another method in here. I'm going to make a method called rectangle data. And this is going to return a string. So the string I'm going to return is height, and x, length, and the word rectangle. So if I have a rectangle, I should be able to call this rectData method and get back a string that tells me, you know, this is a 5 by 7 rectangle or whatever it is. So let's make some different code here. So I'll do rectangle R1 equals new rectangle 5, 7. And so I'm going to print out R1 is a, and I'm going to call the rectangles method that I don't remember the name of. So let's see what I called it. I think it's rectData. Yeah, rectData. So I'm going to print out R1 dot rectData. Right, so this is just another method I'm putting inside my rectangle class. This method gives me back a string that tells me some useful information about the rectangle. So I can say R1 is a, and I can just append the result of rectData to a string. So compile and run that. And it says R1 is a 5 by 7 rectangle. All right. Now if I do this instead, if I just append R1 directly to the string, if I concatenate it, I get something a little less satisfying. I get R1 is a rect @ 16B98E56, right? Now this is probably a more useful way to look at R1 than this. This has meaning inside the virtual machine. It knows exactly what rectangle this is. But to us, that doesn't really tell us anything other than, you know, it's an object of type rect. But this is a really nice output. It would be cool if we could get this output instead of that output. And we can do that. So we have to change something in our rectangle class. But the only change we have to make is we have to call this rectData to string. And we also have to say it's public. All right, when I do that, something really cool will happen. The next time that I try to concatenate a rectangle, right, R1 is a rect, the next time I try to concatenate a rectangle to a string, instead of calling it rect @ and a funny hex number, it will look in this class for a method called toString. And if it finds a method named toString that takes no arguments, returns a string, and is declared to be public, it will take whatever that function returns, and it will use that right here. All right, so what does this mean when I compile and run? It says R1 is a 5 by 7 rectangle. But all I had to do to get that to print was just append R1 to a string. So if I say R2 is an 8 by 10, I can say R2 is a, and append R2 to it, and it will go ahead and replace that rectangle with the string 8.0 by 10.0 rectangle. And so this is something that we do in a lot of classes. We add a toString method, right? Something like this, that will be replaced, will be used to replace the object when we try to concatenate it. And you know, we could put anything in here that we want. We could say, for example, let's just return ha ha ha. Well, when we run this, it says R1 is a ha ha ha, R2 is a ha ha ha. Right? So you can return anything that you want, but usually we want to return something that's in some sense a meaningful representation of the object, so that if we try to append the object to a string, it appends something, you know, useful, like this is a 5x7 rectangle. So that's the toString method. If I don't make a method called toString, there is still a toString method, but it's not the toString method that I've written, right? So if I get rid of this and I append something to a string, it still does some kind of conversion of that object to a string. So if we look at the Java documentation, you'll see that a string is actually a type of object. And if we look at an object, it has a method called toString. And toString returns the name of the class, an @ sign, and then a hash code, right? A hexadecimal code that corresponds to the particular object in question. And so that's the default behavior of concatenating an object to a string if you don't say otherwise. But we're free to say otherwise and, you know, do something useful like that. By the way, if I do something like this and I try to compile, I will get an error. It tells me unreachable statement at line 22 of rect.java. And if I go to 22, it's right here. So the compiler actually understands that when I get here, I'm going to exit my function. I'm never going to execute this statement. And that's a serious enough error that it will refuse to fully compile your program into bytecode, right? I won't get a class file for that. So it's again, you know, trying to save you from the sort of small mistakes that that aren't a big deal in themselves, but probably represent some kind of, you know, logic error or syntax error, misplacement of brackets, things like that. So a fair bit more trying to take care of you than, say, the C compiler does. All right, so that's the toString method. Next thing I want to look at is how to do input from standard in. All right, so our next topic is scanners. And so let's take a look at the documentation for a scanner. And scanners are not automatically available in our Java program. We have to do what's called an import. And we have to import from Java utility scanner. So we'll see how to do that. And scanners can be constructed with a variety of methods. We're going to construct it using a pre-existing input stream called system.in. And once we have a scanner constructed, we're going to use two methods mainly. We're going to say has next line to see if there's another line of input available from the scanner. And then if there is, we're going to call a method next line, which will read in one line of input and provide it to us as a string. So it's kind of like fgets, but it's going to work a little more cleanly and consistently than fgets does in C. So let me go ahead and start some code here. And I'm going to change my aliases because I don't want to keep reusing the same program S1. So I'm going to say alias C equals quote Java C. And I'm going to alias R to just Java. So now when I want to compile, I can say C s1.java. And when I want to run, I can just say R s1. And then, if I trust my command recall, I can do !C to compile and !R to run. But, be a little careful with this kind of thing, because if you accidentally had an rm-rf star and you forgot about that and I say !R, I might recall that command. But, do something that makes sense for you. So let me start a new file called S2 just so I can keep some of the older code away. And I'm going to make this example code. I'm trying to type with my microphone in the way. Example code for scanners and such. So I need an import statement. I'm going to say import java.util.scanner. And again, how do I know that that's what I need to import? Because in the very top of the scanner documentation, it tells me this comes from Java Utility Scanner. So I have that import statement, and then I'm going to have a main program, and here's what I'm going to do. I'm going to do scanner, and I'll just call my scanner SC for lack of a better choice. Scanner SC equals new scanner, and the argument I'm going to use for the constructor is system.in. So this will read from standard in. And then I can say string buffer equals sc.nextLine. And I'll just do a print message, and I'll say the line I read from SC is, and I'll just print out this thing that came back from the nextLine method. So nextLine, we can look at the documentation for it. And it says it advances the scanner past the current line, returns the input that was skipped. So it basically moves down past the new line in the input, right? And it gives you the stuff that it just went over. So it's doing the same thing as fgets, reading in one line from our file. So I compile s2.java, and then I can run s2, and it just kind of sits here. So it's sitting here inside this next line method, waiting for me to type something. So this is my runtime input. And it tells me the line I read from SC is, this is my runtime input. So I can do this in a loop, right? So I could make a while true loop. And I can, read input forever. Right, so everything I type, it reads in with that next line method, and then it goes back to the top of the loop. Now, if I want to get out of this, right, normally the way we indicate end of file is to hit a Control D. If I do that, I get an error. And the error is no line found. It's coming from line 9 of my program. And it's also telling me that, line 9 called the next line method in this scanner class. And at line 1651 of scanner.java, that's the source code for the scanner, that's where it encountered the error. Now, if I had the source code, and you can download the source code for the stuff, you could look at this line and see exactly what was going on. But we can figure it out from the code, because we should not just blindly call next line. What we should always do is say has next line, and that will tell us if there's another line available. And then once it tells us, hey, there is another line, then we can go ahead and we can use next line to actually read from the input. So instead of saying while true, I can say while sc.has next line. And so that will check to see if there's another line available. If I type something and hit enter, this will come back as true, and then this will read in the next line from my input. If I hit end of file, Control D, this will come back as false. I will exit from my while loop, and I can print out a message saying end of file detected, goodbye. So now if I run this, I can say hello, cool, bye, and now when I hit Control D, it just says end of file detected. So very nice controlled way to get out of my input loop. You know, this is reading from standard in. So for example, I could say run S1 or S2, and I could say less than S1.java. I'm redirecting standard in to come from this file. And when I run this, it says, you know, the line I read was class S1, public static void main, all of this stuff, right? It's reading from a file instead of reading from my keyboard, but it's still standard in, right? It's still Unix. We still have these standard input streams we can redirect. I can also do something like cow say hello and pipe that into my run of S2, and now it reads, you know, the lines from a talking cow. So so this is just good old standard in, just like using fgets or getcar to read from standard in C. So we have a way to get input into our program, but our input is always a string, right? So if I run this and I type 23, it says the line I read is 23, but that's not an integer, right? It's a string containing the digit 2 followed by the digit 3, a pair of characters. And so if I want to do something like, you know, double this, I can't just multiply it by 2 because that is a string and you can't multiply a string by 2. I would need to convert it to an integer to be able to do something like manipulate it arithmetically. So in C we use scanf, is the preferred way to convert from a string to a number. Some people use A to I. But in Java we have a different way to do this, and we can use a method in a different class which is called integer. So let me pull up the documentation on the integer class, and integer comes from Java language, so it's built in, and it's basically a class for holding integers. And it has a number of interesting methods available. For example, bit count, which returns the number of 1 bits in the representation of this number. It's got a method of interest to us right now, which is called parseInt. And parseInt takes a string and returns an integer, which is the decimal value of that string. All right, so there's 2 side concepts we need to talk about here. The first is the notion of what's called a primitive. So people like to say that in Java everything is an object, right? Which means everything is an instance of a class, but it's not actually true. There's a few exceptions. There are things like ints, int, doubles, double, boolean, boolean. These things are not technically objects. They're what are called primitives. And you notice that this type of variable, int, begins with a lowercase I. And I've said classes should always begin with an uppercase I. Well, when I say int x, I use a lowercase I on int. And that's our hint that x is not quite an object in the usual way that, say, string name makes name an object of type string. These are primitives. They're shortcuts. It's because we do a lot in coding with integers, characters, booleans, things like that, and the designers of a language want to spare us from having to constantly say, you know, int x equals new int parentheses 10, instead of just saying, you know, int x equals 10. So there's several primitive data types that we identify with a lowercase letter in the beginning, and we can just use them the way we use them in C. Ints, characters, doubles are standard examples. But there is a type of integer which is actually an object of type integer. Integer is a class. Now this is with an uppercase I in the beginning, and it's spelled out integer. when we construct an object of type integer, it comes with all of these methods available to it. So that's one concept, is primitives. The second concept is this keyword static. And when we have an object like sc and we want to run a method, we say sc.methodName. And when we had a rectangle like R1, we wanted the area of that rectangle, we said R1.area. But there's methods that are useful inside this integer class, such as parseInt. And parseInt takes as an argument a string, and it returns an int. This is kind of like a general purpose utility function, right? It's not associated with a particular instance of an integer, uppercase I. It's just a method that happens to be in this integer class, but it's a method we might use, in a lot of different contexts. And so it's got this keyword static. And static means that if we want to run this method, we can use the name of the class integer period parseInt. So let me show you what this means. So let's read in a line. Let's print out what the line is. And then let's just say integer value equals integer parseInt. And I'll just parse this buffer that I read. Typo City here. So integer.parseInt, right? This is similar to when we say r1.area or sc.nextLine, but integer is not an object, it's actually a class. And in a lot of cases, we run these methods as part of an object, an instance of a class, but sometimes it makes sense to just run this as part of a class. And in those cases, this method is identified with the keyword static. So if we have an integer and we want to convert it to a long, we can just say, name of the integer object dot long value. But if we want to take a string and convert it to an integer, we just want to use this method parseInt that's part of the integer class. So it's defined static, and when we want to run it, we say name of the class dot parseInt. So let's see what this looks like. So let's try to parse this string as an integer and print out its value. And then we'll multiply it by itself just to convince ourselves that this really is an integer that we're seeing and not just the string that we got back from nextLine. So I'm going to call nextLine. I'm going to print out what the line is that was read. I'll parse it as an integer, and then I'll print out its value, and then I'll multiply by itself and print out that value as well. Oh, so exclamation C brought back my last C command, which was cowsay. So I'll compile it with compile s2.java, and then I'll run s2. And so I can type in like 23, and it says the line I read from SC is 23. When parsed as an integer, this has the value 23. When multiplied by itself, the value is 529. So I'm successfully taking this input string, converting it to an integer, and then I can manipulate it like a regular integer. And if I do -10, it's -10. When I multiply myself, the value is 100. The trick here, of course, is if I type in something like haha, it says the line I read is haha, but when I try to convert that to a number, I get an exception. Exceptions are just errors. They're controlled versions of segfaults, if you like. And the error is happening at line 11 of Java, of my Java program S2. But you can see that at line 11, I called this parseInt function, and at line 770 it called another function, and at line 652 it called something else, and that caused an exception at line 65 in this other file. So we're mostly interested in line 11, so let's take a look at line 11. So I'll do 11 Shift G, and right here there's the parseInt. Alright, so we can get exceptions, and this is a really common exception. Type in a number and you don't type in a number. So let me add something else in here. So let me put a prompt in here. So I'm going to say system out print, and I'm not going to say print line because I don't want a new line. I'm going to say enter a number, and then I'll try to read the next number. This is not where I want to put this prompt though, because if I run this, I don't see the prompt until I type in my number. And the reason for that is that, remember, when you call has next line, this is where the system is sitting waiting for input to appear. So if I look at the documentation on Scanner again, and I look up has next line, it tells me this method may block while waiting for input. So blocking, we touched on this in some other lectures, blocking means that this function call will not come back until something happens. Either it detects end of file or someone hits the enter key. So what I really want to do is put my prompt outside my loop, do that initial prompt, and then do it again at the bottom. So it will prompt me first, it will go into my while loop, and then after it prints this out, it will prompt me again, go back up here and wait for more input. So if I run this, enter a number 2, enter a number 4, enter a number 1, and then Control D marks end of file. Alright, so let's do something about this business of getting an exception. You never want to get an exception message like this in your programs. We want to handle those. So there's a new concept to introduce here. This is the idea of catching an exception. And the way we catch an exception is by putting it in what's called a try-catch block. So, so the following statement may cause an exception. So I'm going to put this in a block which says try, and I'm going to put the statement or statements that I want to try inside this block. And let me do this the way that I don't want to do it originally. And then I'm going to have a catch block. And in my catch block, we can think of it kind of like a function call. If an error happens in here, the code inside this following catch block will be executed, and it will supply an argument to this block which tells me about the exception that occurred. So I need to specify something like an argument list here. And I'm just going to say, hey, I want my argument to be of type exception, and I'm just going to call it E. And so if we get here, an exception occurred, and E contains info about the exception. So I can print something controlled here. Something went wrong. And that's the end of my block. Alright, so this is something we're going to do a lot, especially as we get further in the course, try-catch blocks. So same setup as before, except before I try to call parseInt, I'm starting a try block. And if anything goes wrong in this try block, I will jump down here to this catch block and execute this chunk of code. So instead of throwing an exception on the screen, I should just get a nice message saying something went wrong. So I can do a 3, I can do a 4. If I say haha, it says the number I read is from SC is haha, and it says something went wrong. And now I can put in another number. Right? And so it understands what an integer is, and if the input does not parse as an integer, it will throw that exception and say something went wrong. And then when I'm done, I can hit Control D. There's the end of file. So now I have a nicely controlled program. It's not printing out, all of this alarming stuff up here, which I don't want my user to see. I'm just printing a message, or I could exit the program quietly, or whatever. Now this variable, this object E, is potentially useful. Let's take a look at its value. So I can say E equals, and let's just print out the value of E by concatenating it to this string E equals. So if I enter a number, haha, it says E equals Java language number format exception for input string haha. So it's got a lot of information available. And if I look at has next line, it tells me it can throw an exception, illegal state exception. Sorry, let's look at parseInt. ParseInt can throw an exception, number format exception, which is what it told me E was. It was a number format exception. Well, a number format exception, that's a type of object. It's a class. And I can click on that and see that that's a version of an illegal argument exception, a runtime exception, an exception, a throwable, and an object. And in my code, you notice that I did not look for a number format exception. I looked for exception. Well, that's like a superset of number format exceptions. So that's the most general thing to catch. Ideally, I should have put, a number format exception, but for the sake of developing test code, we're fine just saying, let's catch any exception here. But if we want to know more about what exceptions look like, well, we can click on that, and, exceptions are a class, and they come with methods. So what are some of the methods that we can execute for an exception? Add suppressed, fill in, stack trace, get cause, get message, and so on and so forth. So I could look at get message, and get message gives me back a string version of that exception. I could say print stack trace, and that prints out to standard out what the stack trace was. Or I could say get stack trace, and it'll return an array of stack trace elements, which I can convert to strings. So if I wanted to put that long, horrifying output on here, I could just say e dot print stack trace. So I could say stack trace follows, then I could call e.print stack trace, and that should go ahead and print out the stack corresponding to that exception. So now if I type in something illegal, it shows me something went wrong. It prints out the string value of the exception, and then my message was stack trace follows, and there's the stack trace. And my program is still running, and I can continue, having it do what it's supposed to do, or typing errors. All right, so try-catch blocks will be key, and we'll play around with those. Today. So one more example of this. We're putting in, we're doing a parseInt, and we're saving this as a value. But this has to be in the try-catch block, because this method call can throw an exception. But these print statements cannot cause an exception. And in general, we want to keep our try-catch blocks as small as possible. I could theoretically put my entire main program in a try-catch block, and if anything went wrong anywhere, I would jump down to a catch block and say, something went wrong. But when you use try catch, you really want to keep those blocks as small as possible so that they only go around the particular statements that you're worried about. So really what I should have done was taken these two statements and put them outside of my try catch block. And then let me get rid of the stack trace because it kind of gloms up the output. And then down here, I could have said continue to go back to the top of my while loop. But if I try to compile that, I'm going to get an error. And the error I get is cannot find symbol value. And that's at line 24. And that's right here. And this happens a lot when we move code into something like a try block. Because I said integer value, I declared my variable value right here, which means it only exists within this block of code. So the fix is not to move these statements inside here. The fix is to move the declaration of value outside the block. So I'll just put this here and a message saying save converted value here. And now when I compile it and run it, it works fine. And as we get into more complex classes and we find we have to put try-catch blocks around more pieces of code, this will pop up and get us once in a while. So just remember, declare your variables outside of try blocks if you plan to use the value of the variable outside the block. Another thing is, when I run this and I get an error, it prints out, the error message, but I don't get my prompt again, right? The reason I don't get a prompt is because I didn't tell it give me a prompt. I said, hey, when something goes wrong, just go ahead and continue. So to make this look a little better behaved, I can go ahead and right before I say continue, I can print out my prompt again. So now it keeps prompting me when I get an error. It'll say something went wrong, and then it'll ask me again for a number. So just, little details. So the last thing I want to describe is the double class. So double is another class like integer. And double is cool. It comes with some fields that we can use. For example, max exponent, max value, min value, NaN, constant, which means not a number, positive infinity, negative infinity, right? These are all fields within double. So if I say uppercase double dot positive underscore infinity, that's a double precision floating point number that represents positive infinity. And it's a legitimate value in IEEE 754 floating point representation. So those are useful. And then again, there's a bunch of methods, including parse double. And parse double takes a string and returns a double. So if I want to write my program here, but have it work with doubles instead of integers, what do I have to do? I just have to make a few changes. So I'll make value a double, and I'll say value equals double dot parseInt. And I think everything else should work exactly as before. So compile that. But it's not parseInt. It's double dot parse double. So now when I run this, it works as before, but I can put in something like, 1.5, and it'll double it and get 2.25. And if I put in something like 2.x, that will still give me an error. It'll say something went wrong, number format exception. But if I put in a valid double, it will go ahead and do its thing. So we want to get good at using the documentation, and when we start working with a new class, we want to look at the overall description of it up here in the beginning. We usually want to take a glance through the different methods that are available, because there's a lot of methods packed into these things. And you know, a double in C is just a number. It's a 32-bit number or a 64-bit number, holds a binary pattern that represents a floating point value. But in Java, a double defined, you know, with an uppercase D has a bunch of functions available, methods that we can run to do things like see if it's equal to another value or convert it from a double to a float, and so on. And double also comes with these static methods like parse double, or toString. If we have a double and we want to turn it into a string, we can call a toString method. Well, remember, toString is a method that's automatically called when we do concatenation. So if I have a double and I try to append it to a string like this, the system calls the toString method for this, which converts it to a string. All right, so we're starting to move more in the realm of thinking about objects, working with objects as something other than just simple variables or simple structures. We're starting to get into the methods that we can execute associated with an object. So we're going to continue in that path. In the next class, we're going to look at some other nuances about methods, something called signatures. We'll start looking at how we can hide certain information by making certain parts of a class private so that other code can't interact with it. And we'll also start looking at linked lists, and we'll play around with a linked list class that's available in Java. All right, so we'll be doing that next time.